Alright, here we will discuss about the resonant curve. So what do we mean by resonant curve? Resonant curve, it is a curve between the current and the frequency. If you take frequency along x-axis and current along y-axis, then you will find, the variations between the two, you'll get like this type of curve. Which means, as you increase the frequency in the AC circuit, the current starts increasing, and when the frequency becomes FR means becomes the resonant frequency. So when the frequency of the supply reach the resonant frequency, you will find the current is maximum. And if you further increase this frequency beyond the resonant frequency, then you will find the current now starts falling down. Okay, so this curve is known as a resonant curve. Okay, now looking at this equation of the resonant frequency, we see that this resonant frequency here is independent of the resistance because we don't have any capital R here. Okay, but the sharpness of the curve depends upon the resistance. Why? Because this current, the maximum current at resonance condition, it is written as E naught upon R. So when R here is the resistance, so that means the maximum value depends on the resistance. When the resistance is more, the current will be small. When the resistance is large, the current will be. When the resistance is small, the current will be large. Okay. So it means if I have two resistance, one is, let's say this is my small resistance, and I take another resistance which is large resistance. Okay, look, see, this curve here for small resistance, it has a higher peak compared to the curve with large resistance. This is because from this equation. Okay, so the sharpness of the curve, it is always determined by the resistance. When the resistance is small, the curve is very sharp, or we can say it has a very large peak value. But when the resistance is large, then the curve will have a less peak value, okay, which means a less maximum value. Okay, now this resonant curve, I mean the sharpness of the curve here, it is determined by a quality which is known as quality factor, or in short we call Q factor. Okay, so what does this Q factor mean? This Q factor, it is defined as the ratio of the resonant frequency to the bandwidth. Okay, so for that I need to draw another diagram. Okay, so to understand about the quality factor, we consider this figure here. So this is a resonant curve in which the current is maximum at this point, which happens at a resonant frequency omega r. Okay, now if you consider any two frequency on either sides of the curve, let's say this is my frequency omega 1 and this is a frequency omega 2. Now at these two frequencies, what happened is the current at this point, it becomes 1 upon root 2 times the maximum current at resonant. Okay, so this quality factor, which is denoted by Q, I can write it as omega r, which is right, because quality factor is defined as the ratio between the resonant frequency to the difference in the frequency in the two sides of the resonant curve, which means omega r is equals to, quality factor is equals to omega r upon omega 2 minus omega 1, or I can say omega r upon delta omega. Okay, so this delta omega, sorry, it is twice delta omega, and this twice delta omega here means the bandwidth of this curve. So this is the width of the curve, and this width is known as bandwidth. Okay, again, here we have chosen that this omega 1 can't be written as, suppose if this is omega 1 and from here to here, let's say the difference of the frequency, let's say it is delta omega. So therefore this omega 1 can be written as omega r minus delta omega, and this omega 2 can be written as omega r plus delta omega. Okay, so when you subtract omega 2 minus omega 1, you will get, substituting omega 2, you'll get omega r plus delta omega minus with omega 1. Omega 1 is this value, so when you substitute, you'll get omega r minus delta omega inside bracket. But when you remove the bracket, okay, this now become plus. So this minus omega r with this cancel, so omega 2 minus omega 1 is equals to delta omega plus delta omega, mean twice delta omega, and this is known as the bandwidth of the curve. Okay, so that is why bandwidth is written as 2 delta omega. So from here, this 2 delta omega can be written as omega r upon q, which means if the quality factor of the curve is more, then the bandwidth will be small. When the quality factor is more, it means the curve is very, yes, when this is more, this is small. This is small means when the quality factor is very large, the curve is very sharp. When the curve is very sharp, like in this case, okay, if the curve is very sharp, then the bandwidth will be small. But when the quality factor is large, is small. When the quality factor is small, then you will find the bandwidth is large. When the bandwidth is large, it means the curve is very flattened. Okay, so another point here is these two frequencies, omega 1 and omega 2, they are known as the lower half frequency and the upper half frequency of the curve. Alright. Okay, so I think this is enough for the resonant curve, and we shall see some more topics in the next video.